Hi, everyone. So today, Thomas and I want to talk to you for a little bit about how to build a private logging pipeline specifically for mobile devices. While we are the ones presenting these best practices, it's important to note that this is also work based on this is based on work that's done by other Googlers across Android and Google. So I do want to start with differentiating between mobile device logging and other types of more expectable logging like server-side logging or desktop logging. So we do operate under certain technical constraints, for example, power, bandwidth, battery usage constraints. And also there are privacy aspects to this logging. It could potentially be more sensitive than the other types of loggings mentioned. And then also, when we are logging, we're supporting critical use cases that might create outages for billions of users because that is the scale that we operate at. So having said that, it is a privacy conundrum. It's a conundrum for privacy engineers when we do want to launch the best products, but at the same time, not at the cost of user privacy. So what are logs typically used for? So they are used to support these use cases, typically system health, A/B testing, debugging, etc. And this is what an average logging pipeline looks like. So basically, there's this app that triggers a logging request and sends a bunch of log events to a central on-device pre-processing server. And here, these logs are typically batched and other processing takes place, and including some privacy protections that are the on-device privacy protections. After this, these logs are uploaded to the server side where there is further processing that takes place, and then also the second level of privacy protections are applied. And then these logs are sent to more specific data stores for further downstream processing and usage. So when we're talking about on-device privacy policies and enforcement, what we're trying to, the basic goal at this stage is to minimize data collection. And by minimizing data collection, I mean minimizing in terms of size and volume, as well as in terms of sensitivity and granularity of the user data that is collected. So how do we minimize or reduce data collection? For that, we first need to understand what kind of data do we actually collect. And in our experience, you can do this by knowing these three things about your data. So what is the type of the data? What are the controls that enable this data collection? And also, what are the purpose limitations for this data? So like you see in the slide, this is an example of how your data can be annotated. This is taken from AOSP. This is the Android open source version. You can see that the first field is annotated by its data type, while the second field is annotated by the usage policy that corresponds to that data type. So once you understand this data, you can basically then define and enforce policies at the collection level to block unnecessary uploads. And this is how you attain the goal of data minimization. So once you have the basic structure figured out, you can add more privacy features to your logging pipeline, depending on what kind of use cases do you usually cater to and what kind of data do you usually see. So here, we know that from our experience, local differential privacy is, although it's the gold standard, it is hard to implement on logs specifically. But I do want to touch upon string handling because you could potentially inadvertently end up logging sensitive SPII or PII strings in your logs if you do log free-form strings. So the typical way we recommend to solve for this is that anytime a free-form string enters your logging pipeline, it should be automatically scrubbed. This does create the intended motivation for teams to look for other types of logging, alternative logging. So for example, a team that was previously maybe logging exception messages now would consider logging exception class types via enums. Similarly, when we're talking about identifier choice, we know that we should remove identifiers or use rotation-based and resettable identifiers wherever possible. However, it's not so straightforward a decision in some use cases because when you are removing identifiers, you are also removing the user's ability to delete that data. As well as in our experiences, we've seen when you go and actually implement privacy techniques like differential privacy and k-anonymity, it is harder to implement these on data sets that do not have an identifier. So there are these trade-offs that you do need to think about. Similarly, there's another use case that I want to point out, like teams do introduce identifiers for use cases where they want to log or know the number of unique users or devices using a certain feature. But we have seen alternative solutions be successful. For example, if a device basically generates a one-time unique ping to the server, and on the server side, you basically compute you add all of these, you count all of these pings, you can generate metrics like monthly active user or daily active users, and that definitely helps preserve the privacy benefits of a system. So overall, from the on-device policy enforcement, I do want the takeaway is that this is where you can have the maximum privacy impact by ensuring that no unnecessary data leaves a user's device.
So at this point, we've talked about how we get data from the client device to the servers, but obviously the pipeline doesn't end here, right? We'll have a lot of people actually accessing this data, using it in all kinds of ways, retaining it, transforming it, and so on. And so we have the logging pipeline that we were trying to design also has to keep going server-side. Ultimately, the goal that we have server-side is that people should only get access to what they actually need. And we want to be as specific as possible, right? If you're trying to debug a specific production problem, you should be able to get access to the data which is relevant to that problem and which is also tagged as being debugging data, for instance. So we do that with different aspects, right? The first one is policy. Policy is quite nice because it's cheap at runtime compared to some of the technical solutions. It's understood that it cannot be verified client-side when we're talking about like server-side policies. So definitely it doesn't help with trust as much, but it's very impactful in terms of actually protecting user privacy. So in terms of policies, we have a lot of things which are specific to server-side. Usage, retention, and access are the three I'm highlighting here. So when I'm talking about usage, if we think back to the annotations we talked about client-side, if we annotate some data as being debugging data, for instance, we want to make sure that when we have a pipeline or a user actually using that data, they also have to be doing debugging, right? So you have also like tagging server-side, for instance. When it comes to retention, we know that different data types have different sensitivities and they've been processed in different ways. So we can build policies which allow people to retain data for different periods of time depending on the specific types and processing that was done on the data. And access is kind of the obvious one, right? If you have a team which adds new metrics, they should be the ones who are eligible to get access to the data. If other people outside of the team want to get access, there has to be a process for that. So we have all these policies, and of course we audit as well. So we want to make sure that we are consistent and that people are not abusing the system. So on top of these policies, of course, we have a number of technical solutions as well, which happen server-side. The first one is shuffling. So shuffling, it's used, for instance, on Fuchsia. There's some papers about that. They have this infrastructure called encrypt, shuffle, analyze, where the logs are going to be merged together, shuffled, aggregated, and analysts only get access to this aggregated view, and only this view is retained. So that's a pretty strong solution. Random sampling is fairly straightforward, right? So we're thinking about collecting information from either a random set of device, or we can also do sampling at the event level. So event level sampling is going to be client-side. Server-side, we can do device level sampling. And it seems pretty straightforward, right? You want as few devices as possible sending the data. That improves the privacy of the devices not sending the data. But there's a trade-off here, because if we do it too much, we only have a few devices sending data, and at that point, it hurts the privacy of the people actually sending. So we have to have solutions in place to make sure that people are not going overboard with the parameters, for instance. The last one is cross-device aggregation. That's the most technically complex, right? And this is the kind of stuff we usually hear about in these presentations. It's expensive, right? If we're talking about like federated analytics, secure aggregation, techniques like private heavy headers, for instance, there's some use cases at Google, right? This is used for like now playing on Pixel phones. This is used in like Gboard. There's a bunch of papers about this. But yeah, we know this is expensive, but it's important to have the infrastructure ready and to make it available to every team, right? So if we identify as privacy engineers, when we work with product teams, we identify use cases which are compatible with this, we want to do it as fast as possible. And a few more. So key anonymity. Everyone's familiar with it. It's not the best privacy guarantees. We know there's a lot of attacks on it, but at the same time, it's very effective at actually protecting user privacy, especially if we do it, not especially if we do it client-side, but client-side is expensive. It's hard to do anonymity client-side. Server-side is pretty affordable, so we're able to scale it to like billions of devices, for instance, and trillions of log lines if need be, and this is really impactful. Allow and deny lists. Pretty straightforward, right? When we are managing a very large-scale system like Android, we know we have a lot of devices which are out of date and they don't get updates, and so they might send data which we don't actually need anymore. So it's important to both client-side and server-side make sure that we are not collecting anything we don't need. We have to keep track of what's actually needed at a certain point in time. The last one is central DP. So compared to local DP, it's a bit more practical, and so there's some libraries for how to do that on dataset. It allows us to collect the data, and then server-side, when analysts actually want to get access to that data, they actually go through this pipeline, and we make sure that they don't accidentally get access to any individual insights. Now, if we're looking at the future, these are some of the things we think might happen at some point, and this is, very much looking forward. We talked a lot about annotations, and in our experience, annotations have been a very, very helpful tool. It's affordable, scalable, and impactful, but it relies a lot on declarations, right? If you declare your pipeline is a debugging pipeline, we sort of have to trust you, although there can be restrictions on it. And we could imagine a world where we have models which sort of look at how you access the data, how you process it, how you join it with other data sets, for instance, and sort of flag if, oh, this is suspicious, maybe this is not actually debugging that you're doing. So if we had this kind of system, it would help with auditing tremendously. Another aspect is multi-party computation telemetry. There's two kinds, broadly speaking. You have like multiple clients, like multi-party on the client side and multi-party on the server side. So at Google, for instance, for the exposure notification app back in 2020, there was a first deployment of multi-party server side, so with multiple organizations sharing this telemetry. This is something which we would like to see used more broadly by building systems which are fairly flexible. This will help user trust in the system by splitting between multiple entities. And one thing I want to highlight is, as privacy engineers, we want teams to actually use these systems, and so we need incentives to get them to actually invest into them. So just a few things. The first one, it's much better for like a very large project like Android, right? We have hundreds of feature teams. They have different needs. They work on different data. They want to, to keep it for different periods of time and do different things with it. It's impossible for them to each build their own system, of course. So there's a lot of value in having a good system with all the privacy checks in place that's scalable and flexible with all kinds of teams in mind. The second one is how it actually can help reduce costs. That's a pretty good motivation. There have been concrete use cases where we've worked with product teams to, for instance, anonymize their data set. The result was like a smaller data set, and any kind of processing on that data set is also cheaper. And so it resulted in significant savings for them. So that's a pretty good motivation usually. The last one is pretty obvious, compliance. So we're not lawyers, but we work with the legal department, and they sort of advise us on what are the compliance requirements, and we can see what kind of technologies will help with that. To give a fairly obvious example, GDPR explicitly says that anonymized data is out of scope, so that's one way to comply. All right, I think we have a couple minutes for questions. Thank you.